This is lessons 10.6 and 10.7 in geometry. We're going to be looking at the volume and the surface area of spheres. So we're just going to jump right in. These have pretty straightforward, simple, consistent formulas that we're just plugging in the radius. So there's not a lot of variance in these in terms of what we have to find and how we have to do it. You just figure out what the radius is, which is obviously very straightforward. Plug it in, and then just make sure you know how to run these through the calculator. All right, so when we're looking for the volume of a sphere, it's going to be 4/3 times pi radius to the third power. All right, volume is always to the third power. So cubic inches, cubic feet, whatever that is. So we're multiplying something that is, let's say, centimeters times itself 3 times. So our units will be to the third power. And then how we handle the 4/3, you can either use your fraction key, but we're going to go ahead. Most of the time, these do not turn out to be nice numbers because we're dividing by 3 and we have pi involved. And so we're not going to leave pi in our answers most of the time in these. There will be times we do, but most of the time we're just going to get the decimal answer. So you can see here, round your answer to the nearest tenth. That means plug pi in your calculator. And when we get to the 4/3, because we're not worried about getting a fraction, we're okay with getting a decimal in these. We're just going to multiply by 4 and then divide by 3. So we're going to cube this times pi times 4 divided by 3. And you can actually plug all of that in your calculator at once. So we'll take a look at that. And then surface area is 4 times pi times the radius squared. Remember, area is always to the second power. It's always squared, square feet, square inches. So you just take your radius, you square it, times it by pi, times it by 4. Just to be consistent with these, we will also round these to the nearest tenth, although these could very well be left in terms of pi and give you some nice answers there. All right, but we're going to do all of these rounding to the nearest tenth. So let's start with volume here. 4/3 pi times my radius to the third power. I see in my picture, but my radius was given to me. It's 5. I'm just going to go ahead and drop that in. 5 to the third power. And my next line can be my answer. So let's practice plugging this in. I like to just, you can do multiplication in any order. So I always start with my radius to the third power when I'm plugging this in. If you want to go ahead and get that number, you could, but I'm going to go ahead and just put this all in at once. Then I'm going to hit pi, which is second, and then over here is my pi button. And then for the 4/3, instead of trying to use the fraction, because I'm getting a decimal here, I'm just going to hit times 4 divided by 3. Okay, so if I hit times 4 divided by 3, that's the same as multiplying by 4/3. Hit equals. That'll be my answer right there. Again, pi is in that, so we're going to, of course, get a nasty decimal, so we're going to round it. This specific paper says nearest tenth. It could say hundredths, so make sure we know it's tenths, hundredths, and then thousandths, but most of the time we're rounding to tenths or hundredths. So in this case, it's tenths, which is the 5. You look to the next number to see if you need to bump it up. If it's 5 or higher, you would. So the 9 bumps that up to a 6. So it's 523.6. And then centimeters to the third power for volume. And if you forget, you can always just look back. We took something like 5 centimeters and times it by itself 3 times. That's what to the third power means. So centimeters times centimeters times centimeters is centimeters to the third power. All right, and then we're also going to find surface area of this same shape. So just a reminder, volume would be what fits inside of this if you were going to fill this sphere up with, say, water or whatever, or if you're going to create a solid shape made of a certain material, how much is that going to hold, or how much material would be needed to form that solid. Surface area would be if you were forming a hollow shape. So let's say it's a chocolate. How much chocolate's needed on the outside if it's going to be hollow on the inside, or if it was cardboard box. I don't really see where you would use that, but let's say it's a basketball or a soccer ball. How much material is needed to make the outside? It's not solid. That would be surface area. If it's solid, that would be volume. So very easy to use here. Just dropping in the radius again. One spot that we could easily make mistakes. This one's to the third, this one's to the second. So we do need to be careful. Area is always squared. Volume is always cubed. Okay, so that should make sense. Now you can see this would be 25 times 4. This would be 100 pi. So that's a nice answer. We could leave it as 100 pi. All right, 5 squared is 25, times 4 is 100. But since the directions here did say round to the nearest tenth, we need to go ahead and plug this in. So I'm going to go back to the original. 5 squared times pi times 4, and it's 300. So that's just basically pi times 100, 314. 0.1, the 5 bumps it up to 0.2 centimeters squared. Area is squared. And even if you'd gotten all the way to here, if you just did 100 pi, you would get the same answer. All right, so very straightforward. Let's practice one more. I would recommend you pause the video, try volume and surface area on your own, see how you do, and then come back and check your answer. So for volume, again, 4/3 pi times radius to the third power. In this picture, we were not given the radius, right? We were given diameter. So that's what the diameter equals. So the radius is going to be half of that. We're going to need to divide that by 2. So 11.2 divided by 2 is 5.6. So my radius is 5.6. 5.6 on each side, adding up to a total of 11.2. So I'm going to put 5.6 in here, raised to the third power. All right, so we're going to run this through. Again, I would start with this, 5.6. Here's your raise to button, raise to the third. You do need to click to the right. If you keep typing, like if I hit pi right now, it's going to put it up there in the exponent, and we don't want that. So click to the right. That will take the cursor down. Now you can hit times pi. You can also just put pi in. It knows to multiply. And then for 4/3 again, we're going to hit times, because we're timesing by 4/3, times 4 divided by 3. It's all in my calculator at once. 735.6, and the 1 means the 6 is going to stay. My units here is feet. Volume is to the third power. All right, and then let's run a quick surface area. 4 pi r squared. So radius is 5.6. We're going to square it. And let's go straight to our decimal answer here. So 5.6 squared times pi times 4, 394.0, but the 8 will bump it up to 0.1. And the units here again were feet, and this is area, so it's squared. Okay, moving to the back now. So we're going to look at these shapes that are a bunch of different shapes put together. And so we're going to have to find our total volume or our total surface area here. So you can see we've got the cone, the cylinder, and half of a sphere. This first one, we're going to find the volume, so how much fits inside all of these. In that case, we can just run volume just like we normally would, how much fits inside each individual shape, and then combine them. When we get to surface area, we're going to have to be careful. It doesn't quite work as nicely. But for volume, we can just find each one individually and add them up. So let's start with a cone. So remember, volume for all of these is either big B times H or 1/3 big B times H. The 1/3 is your cones and your pyramids that come to a point. And then your cylinders is big B times H. And we just talked about what the sphere is. We'll take half of that as well because it's half a sphere. But let's start with the cone. So the cone is 1/3 big B times H. Big B represents the area of the base. The base is a circle, so that's pi r squared. And the height of the cone is 4. So you can see the diameter of all of these shapes. All of them are formed with circles as their base, and the sphere as well. The circle is the center of it, obviously. So the diameter is 6, so radius would be 3. So we're going to go ahead and drop in 3 here. And we can run this all the way across. 3 squared is 9. 1/3 of 9 is 3 times 4 is 12. So 12 pi. We're going to go ahead and leave pi alone in this question. It works out nicely, so we'll just leave it like that. If you didn't follow what I did right there, so 3 squared is 9 times 4, 36, and then 1/3 is the same as dividing by 3, and so we're going to get 12. Next up, cylinder. So let's find the volume of the cylinder. That would be big B times H. No 1/3, right? It has two bases, doesn't come to a point. So it's just the area of the base times the height, and that gives you your full volume right there. Again, the base is a circle. It's the same base as we just used with the cone. Pi r squared, we'll end up dropping that 3 in there. And then the height of my cylinder is 9. So let's go ahead and drop the 3 in there. 3 squared is 9 times this 9 is 81. So this is 81 pi. So the volume of the cone is 12 pi. The volume of the cylinder is 81 pi. Now we just need the volume of the half sphere. Notice I labeled it half sphere so I don't forget to take half. I'm going to go ahead and put it actually in my formula. So I'm going to take 1/2 of the volume of my sphere because it's half of a sphere. So at the very end, I'm going to take half of my answer here. Volume of a full sphere would be 4/3 pi r to the third. And then I'm going to take half at the end. So let's go ahead and just worry about the inside right now. We already know the radius is 3. We've used it a couple times. 3 to the third. Can't tell you how many people will square it there, so just be careful. And then this looks like it should kind of turn out nasty, but take a look. 3 raised to the third is 27. We'll just leave it in there. Times 4 divided by 3. So let's leave pi out of it for a second. We get a nice 36. So the 3 squared times 4/3 gets me 36. I'm going to take half of that, divide by 2, and that's 18. Because that's a nice number, I'm just going to leave it there with pi. I'm not going to put pi into it and create a nasty decimal. I have 3 nice volumes with a coefficient for pi. Total volume then is just going to be all of these added up. So 12 pi plus 81 pi plus 18 pi gets me 111 pi. Okay, so we're going to slide down here to surface area. Now we need to be a little more careful here with surface area. Think about what this is. This is the outside of the shape. It's measuring all of the area on the outside of the shape. Why we need to be careful is we can't just take the full area or surface area of each one of these shapes, because parts of these shapes are actually on what would be the inside of this three-dimensional shape, and it wouldn't count as the surface area. For instance, with the cone, we just want what's on the outside here. What we would look at as the base, we don't need the area of that base. It's on the inside of the shape. The surface area is just the outside, which we know is the lateral area, right? We break surface area down to lateral area plus the area of the base. So we're just going to ignore the area of the base. We're just going to find the lateral area of the cone. The same thing with the cylinder, right? We don't want to count the area of the bases as part of the surface area here. Those bases are on the inside of the shape. If you were thinking of it like the soup can, it's just the label. That's the only part of the cylinder that's actually on the outside of this three-dimensional shape, not the bases. So we'll use the lateral area of the cylinder. The sphere, though, we don't actually ever count the base as part of the surface area of a sphere, right? It's just the full sphere. So if I just take half the surface area of the sphere, that will work just fine. I don't have to worry about kind of taking something out of it. All right, so let's start with our cone. We just want to find the lateral area. So lateral area of a cone is 1/2 times the slant height times perimeter. Now normally for surface area, we would add plus the area of the base. So we're going to ignore that. We're not going to put the plus b. We're just finding the lateral area here of the cone. Now, slant height is different than height. So we can't just grab this 4 here and use that. So we need to actually go ahead and find it. So right here, the height of this is 4. And we know that the radius is 3. We've used that a bunch of times. It's the same picture as the top. Just finding surface area now. So that forms a nice little right triangle, which we can use Pythagorean theorem. Remember, the slant height is out here. This is the height or the altitude, and this is the slant height. So we actually need the slant height here. So we got to do some quick Pythagorean theorem to find the slant height. These are my legs. My C is the slant height. So A squared, B squared, C squared. That's 9 plus 16. So I get 25. And then I'm going to square root that. And so my slant height here, the square root of 25, is 5. Nice and easy. Let's now go ahead and plug that in. So I'm finding my lateral area here. 1/2 times my slant height, which is 5, times perimeter of the base. It's a circle. The perimeter of a circle, remember, is circumference, so pi times diameter. So 1/2 times 5. The diameter is 6, so pi times 6. 6 times 5 is 30. Take half. My lateral area here is 15 pi. All right, onto the cylinder. Again, we talked about we don't want the area of the bases included as part of our surface area, so we're just looking for the lateral area. Now, a cylinder is like a prism, right? It's different than these. So it's a different formula for the lateral area part. It's just perimeter times height. When we have these shapes that basically form what looks like to be a triangle, remember the area of a triangle is 1/2 base times height. That's kind of where this comes from, your 1/2, your base times your height. It's not exactly that, but it's kind of how you can remember that. Whereas when we have kind of like a rectangle, even though it's a cylinder, when we're looking at the lateral area, we're looking at a rectangle. It's just base times height or perimeter times height. So we got to remember to use different lateral area formulas for our cones and pyramids compared to our cylinders and prisms. All right. Now, the perimeter of the base here is going to be the same as the perimeter of the base was for the cone. So it's a circle, it's pi times diameter, and then the height is 9. So we know the diameter here is 6. So I'm going to go ahead and multiply that together. It's a nice number. We'll leave it here with pi. It's 54 pi. All right, and then last we have the half of a sphere. We talked about we don't have to edit this one besides the half because the surface area of a sphere would be all of it. We're just going to take half, and we don't have to do anything fancy there. So the surface area of a sphere, we're going to take half of it. But that formula is 4 pi r squared. Always double check your spheres if you're doing volume or surface area. You've got the right squared or cubed on it. Surface area is squared. All right, we're going to go ahead and drop the correct radius in, which is 3. We've used that a bunch now. So you could do this in any order. If I was doing this mentally, I know 3 squared is 9, half of 4 is 2, 9 times 2 is 18. So it's 18 pi. And of course, you could run that through the calculator. Just don't include pi. We're going to keep pi out of it. And all we have to do now is add up our total surface areas here. The lateral area of the cone was 15 pi. The lateral area of the cylinder is 54 pi. And the surface area of our half sphere was 18 pi. You add those all up, and you get a total surface area of 87 pi.